Hi, I'm Troy Byers, president of ACG and a commissioning professional like many of you. Together with our fellow presenting organizations, AABC and EMA, I wish I could see you in person this year, but be sure to register for CxEnergy Virtual this April. We'll be bringing you 16 hours of top-notch speakers on commissioning, energy management, testing, adjusting, and balancing, and other builder performance topics. We'll also have a dedicated technology day where you can tune in to see the latest software and tech for our industry in rapid-fire fashion. So go to CxEnergy.com right now and register to join us. Don't forget, members of ACG, AABC, and EMA can attend free of charge. Thank you.
Thank you for joining in, everyone. Before we get started, we're going to watch a quick video from our sponsor, Peachtree Analytics.
Peachtree is on a mission to make sure that smart buildings deliver on their promises. Our AI software, Kaizen, continuously monitors your building's performance, alerting you if a fault is detected or if performance is suboptimal. Our clients use this powerful tool to move from a reactive or preventative maintenance model to a data-driven, proactive maintenance approach. With no upfront capital investment and an affordable software-as-a-service usage fee, Kaizen results in time and resource savings for facility managers and cost savings for stakeholders. We deliver a comprehensive building analytics solution consisting of an energy information system and a fault detection and diagnostics platform with integrated system performance auditing. Peachtree Analytics can help you create operational efficiencies, reduce your building's energy consumption, and improve your bottom line.
Well, good morning, good afternoon, or evening, depending on what time zone you're dialing in from. And welcome to the first 2021 CxEnergy virtual webinar. Of course, we could have never anticipated to have to pivot to a virtual setting for CxEnergy 2 years in a row, but we hope we can make up for the lack of face-to-face time with top-notch educational content over the coming weeks. So starting today, we'll be offering 16 hours of live and pre-recorded technical sessions that would have taken place at our in-person conference throughout the month of April. So before we get started today, I just have some general housekeeping notes to address. In order to receive a certificate of completion, you must be a registered attendee and use the personalized link that was sent to your email address to join the webinar, not one that might have been shared with you. Once each live presentation concludes, you will receive an email with your certificate within 24 hours. Last year, we used the CxEnergy app. Don't worry about it this year. You do not need to download it to receive your credits. Additionally, and this note is for ACG, EMA, and AABC members, if you are a certified CXA, EMP, or TBE, staff will be uploading your certificate of attendance to your respective member portals for you. This will be completed after the final CxEnergy 2021 virtual presentation at the end of April. Another note, all live webinars are being recorded, so if you miss one of them, you'll be able to review it later, 1 week after the live event. During the session, we encourage you to submit any questions. Please do. We love to hear from you, and we'll be holding them towards the end of the presentation to address. The chat function is where you can make general comments and chat with attendees. And then if you happen to be experiencing any technical issues during the webinar, please use that same chat function to inform the panelist, and our technical experts will assist you. So today's webinar is a case study on the new net zero energy ASHRAE headquarters. A few words on our speakers. Darren has 16 years of experience in the building services industry. He serves as a commissioning agent on a wide range of facilities, including university buildings, research laboratories, healthcare facilities, and data centers. And then Ginger is a licensed mechanical engineer with 32 years of experience. She is the president and co-owner of Engineered Designs Incorporated, a full-service engineering firm which she founded 22 years ago. So without stealing any more precious time, I'm going to hand it off to Ginger to kick us off today. Ginger?
Great. Can you hear me okay?
Yes.
You can. All right. Thank you for letting us be here today. We're excited about this project. Let me see if I can move my slides forward. There we go. So our agenda, we're going to go a little bit into the background of this project. We're going to talk about the project goals, the execution, some lessons learned from the owner's perspective, and go into some commissioning items that Darren has been working with us on this project from the time we moved in until most recently. So this project started in early 2018 when we formed a volunteer ad hoc committee to study what we should do with our existing ASHRAE headquarters in Atlanta, Georgia. I was vice president of ASHRAE at the time and was chosen to be head of that ad hoc committee to see what we needed to do, because we had a situation where we had a very nice building that we renovated in 2010 to a LEED Platinum level. It was about 35,000 square feet. It was full to the gills, if you will, with employees and learning center area, and we were running out of space in that building. And also we had a situation where we had a new neighbor. We had the Children's Hospital of Atlanta had purchased property all surrounding our building. And if you looked at their master plan, our building was going to be situated such that we looked right up the end of their new central plant, which is really not a problem for ASHRAE, but could have been a problem for our property value. So we felt like we needed to study the options of whether we should keep our building or sell it. And lucky for us, we negotiated with the Children's Hospital of Atlanta for our property, and we sold our building at the end of 2018 to CHOA, which started our search for what we were going to do next. We looked at many different properties in the Atlanta area. We looked at leasing, we looked at building, and we looked at buying, and we ended up purchasing a property right outside of Atlanta proper in Peachtree Corners, Georgia. And it's about 66,000 square feet. It's 3 stories. It was your quintessential 1970s building that was actually a headquarters for a technology company before us. We purchased this building in December of 2018. So we started talking about what is our story? What do we want to show the world as ASHRAE that we can do? And we felt like the reason we wanted to purchase an existing building instead of building new is that, you know, most of the buildings that are going to be in use in 2050 have already been built. And most of the buildings built up to and including this time that we're in now are not operating at a very efficient level. And so we wanted to show that you could take some existing building stock and renovate it to an efficient operating building. So we decided our project mission was going to be to renovate this 1970s building into a high performing, net zero ready facility in a cost-effective method, if possible, that can be replicated in the industry. So that was our mission. We started out with our building, and so we selected our team, and we developed our owner project requirements. And our owner project requirements were given to our team when they were selected, actually before they interviewed. And it listed all of our critical items as well as some stretch items. So we had some mission critical items. Number one was safety. We wanted a safe work environment and construction project, affordable. We had an available budget that we had determined what our tasks were going to be for the building. We had some surprises along the way, as you can imagine, and I'll go into that a little bit deeper. We knew we had to meet or exceed our ASHRAE standards. We had some acoustic standards that we wanted to meet, and we knew we wanted the building to be net zero energy ready. We did not think we had enough funding to be able to afford to install our PV panels to get us to net zero, but we wanted to be ready to do that so that we could negotiate possibly with a third party for purchase and lease of our panels. So those were our mission critical goals. These are some more items that are in our OPR with 189.1. We knew we wanted to exceed the requirements of that standard. We had a goal of 21.4 kBTU per square foot per year for energy use with a stretch goal of 15 kBTU per square foot per year. We knew water efficiency. We wanted to get 11 out of 11 lead water use points. We wanted to limit our daytime plug load to 0.04 watts per square foot. We knew we had an acoustical goal to exceed the requirements by 3 to 5 noise criteria. And we had an outside air rate. We wanted 30% greater than ASHRAE 62.1 for outside air. With DCV used for our training and high occupancy areas, and daylighting. We wanted daylighting to really enter into the building so that we had a generous daylighting 55% of the time for our occupants. And we wanted to define our resiliency, what we needed, and be able to meet those goals. So we asked our design team to work with us through that and define our resiliency requirements for the project. So we started with a benchmark, office benchmark EUI of 58 and looked at our existing envelope and where we were with ASHRAE 90.1 2016 in terms of EUI and how we needed to get there. We knew fixing our envelope was going to be the first step in getting us to a low EUI so that we could handle any remaining energy use with our photovoltaic system. So we looked, our design team did a really good job of looking at different envelope options to be able to get us to a point where we could get to our goal of 21.4. So we focused first on the envelope and then focused on obviously, very efficient lighting, and then moving on to our HVAC system and how to right size that and pick the right system that would get us to our energy use. So looking at the climate factors in Atlanta, those of you that live in the South know that we have a very hot summer, very humid, maximum temps in Atlanta in the 98 degrees. Like I said, a very humid condition. We don't design specifically for winter as much as we design to handle summer. So summer is obviously the big load when it comes to Atlanta, Georgia. Starting with our envelope, we're looking at our existing performance of our walls. We knew we had a wall assembly R value of 3, which is extremely low, if anybody can imagine. Our net zero energy design guides require a minimum of R 15.6 for climate zone 3, where Atlanta is located. Our architect did some analysis of cost versus benefit ratios and ended up recommending a wall assembly of R17 with a roof of R35. And then we improved our windows. We ended up having to replace all the windows in the building, and I'll explain mainly because of the window to wall ratio was pretty drastic. If you remember from that first picture, we had a pretty strong amount of windows that didn't meet the ASHRAE requirements for window to wall ratio. So we had to fix that. We knew we wanted to get our infiltration under control in order to make sure our envelope was as tight as possible. So existing window to wall ratio, you can see here on the left, was close to 80%. It was a pretty high number. And so we knew we had to get that down. We looked at several different arrangements of windows and in order to get the number to where we needed it to be, and ended up with a window to wall ratio of 33.5 on the east-west and 41.9 on north-south. So, and gave us, we had to match this with our daylighting requirement of how we were going to get daylighting into the building and reduce our window to wall ratio. So there was a lot of time spent discussing how this was going to move forward. So this slide right here shows what we ended up with our R17 walls and our R35 roof. We looked at our U value for our windows. We got our window to wall ratio down while still trying to get our daylighting into the space. And so one of the ways we figured out to get our daylighting into the space was to add skylights to the building so we could get our our 55% that we were trying to get. So we ended up with an average of 57%, but by adding 18 skylights to the building on the upper level to help get the daylighting into the building, as you can see from this slide. Once we got our envelope under control, we started to look at our HVAC system and what system we were going to end up with for the building. Our design team proposed two options. One was an all-air heat pump system that got us where we needed to be. The second was a hydronic system that also got us where we needed to be. We elected to go with option 2, the hydronic system, simply for the fact that it was pushing the envelope a little bit more than the all-air heat pump system. The all-air heat pump system got us to where we needed to be on an EUI basis, and is a very replicable system, an affordable system that folks can use to achieve these goals. We, however, felt like because we were ASHRAE, we really wanted to push the envelope on systems and decided to go with the hydronic system, which I'll go into here right now. So this was the all-air heat pump system that was recommended. It was, rooftop heat pump units with zone control via the diffusers with high velocity, low speed fans, raising the temperature in the space to around a 78-degree set point. Because of the use of fans, we could do that and still make the air feel a little bit cooler. It was proposed to use operable windows, which if you know anything about Georgia and the pollen season, is not something that we could end up doing. Other areas of the country might have that opportunity. So this was the option 1. Option 2 was the hydronic system with dedicated outdoor air units on the roof. With desiccant wheels, and I'll go into that a little bit deeper in a minute. With radiant ceiling panels, and we ended up not using geothermal, but using a water source heat pump chiller for our water source in the building. So this is a piping diagram of the system, if you will. You can see the heat pump chiller on the left there through our buffer tanks. That's a 4-pipe system with primary loops going into the chiller, both for the heating and the cooling, and then changing to two-pipe loops that go out to the radiant panels that could be either heating or cooling depending on what the zone was calling for. In the south, we don't typically need heat on the interior of the zone, interior of the building. We usually have two-way valves, cooling only zones, interior, and then heating and cooling zones on the perimeter. We also ended up with some heat pumps for the basement, the lobby, and the atrium, and that loop is fed off of the return water from the radiant panel loop. This is a little diagram of our heat pump chiller, which is a different type of device than has typically been used in the South, but allows heating on one module, cooling on another. The other one could be in standby. They could all be in cooling, all be in heating, depending on the load and what the temperatures are in the loop, in order to maintain what we need to get the building temperature where we are. We have 2 dedicated outdoor air units on the roof. Those are DX units with energy recovery, and they feed into some air valves, supply air valves on the supply side, and exhaust air valves on the exhaust side, and preheat and pre-cool the air as it goes into the building on to get our ventilation as we need to. This is an airflow diagram of the DOAS units that are on the east and west, as well as the water source heat pumps that are in the atrium area. So the DOAS units, like I said, feed the outside air valves and feed the exhaust valves, as well as feed ventilation air into our water source heat pumps that primarily are located in the basement, and also for the atrium. The atrium didn't have a ceiling, and so there was no area to really put the radiant, and so we decided to go with water source heat pumps for the atrium. This is just a diagram of one of the exterior rooms, and the radiant panels you can see there in the blue, which are the two-way valves for the interior panel, and then the 6-way valve for the exterior panel. And so these rooms also, since these are meeting rooms, are fed from the DOAS units with displacement ventilation that is delivered to the room at a little higher temperature and closer to the floor, a little at a lower velocity, so it's not disruptive to the occupants of the room, but it is delivered through those chases that separate the room. So the radiant panels form clouds above the ceilings for occupied spaces. And like I said, there's heating and cooling on the perimeter and just cooling on the interior. And the ventilation is delivered at a dehumidified room temperature level, if you will, so that it's outside air, but it's not involved in the heating or the cooling of the space. Just another picture of the area between the clouds and the radiant panels. And these are the radiant panels, the back of what you can see, they're piped in series. You can do up to 64 square feet of active panel in one loop. There's quick disconnects of the hoses and PEX piping to the panels. So this diagram shows one of the zones with the six-way valve. So you can see on the detail on the right, the six-way valve takes hot water or chilled water from our secondary loops, and it decides based on the zone temperature whether the zone needs cooling or heating. And if it needs cooling, then it closes the port on the hot water side and allows chilled water to flow into the zone. And if it needs heating, the reverse happens. Picture of our dashboards. So we are in the process of getting our dashboard completed with our meters. We have meters for all different systems. As you can see here, we've got our main building electric meter. We've got plug loads. We've got lighting. We've got several for our different mechanical equipment components. We've got BTU meters and makeup water. So we'll be able to monitor how the building's doing in real time. And all of this information will be available on the ASHRAE website for folks to track or to look at if they're interested in the future. This was our final layout, excuse me, upper level, conference rooms, offices, F shows, which is full-size hoteling spaces, if you will. For folks to have office space if they need to have a gathering of just one or two people. And the middle level is our training center on the right side here. We have a very large training boardroom at the top, and then several other training conference rooms throughout the space for our, we put on a lot of conferences. Our Atlanta chapter meets in the building. And so we have a lot of space for meetings to occur. And then our lower level is mainly storage and mechanical space, which is one of the reasons also that we used water source heat pumps down here. We were not wanting to spend as much money down here to put radiant panels as we did on the upper two levels. Some pictures of the final product, if you will. Our mechanical room, our pump room really is over here to the left, and the piping that runs out to the heat pump chiller is to the right. A picture of the ceiling. You can see the six-way valve here, and you can see the skylights and the radiant panels and the fans in this area. And this is the back of the building. It backs up to a small lake that runs behind the building, and we have a deck that looks out over that lake. So how did we do, right? So we had our goals, and then how did we meet those goals? Our 189.1, we achieved the areas within the project scope. Site energy consumption, the goal was 21.4. The model estimates 18.5 kBD per square feet per year. So we have by model achieved the goal. We're in the process of verifying that model and the energy usage, although this year is not going to be a good year to do that because the building is fairly lightly occupied at this time. Water efficiency, we have not applied for LEED yet. We want to do LEED EBOM, existing building operation and maintenance, and LEED 0. Both of these require a year's worth of energy data to be able to certify, and we don't have that information yet. Daytime plug load, we are measuring that. Again, it's going to be difficult this year due to lack of occupancy in the building. So most likely this measurement and verification is going to need to continue on through next year once everybody gets back into the office. We had our acoustician come out and verify our acoustics to make sure that we met our goals there. We ended up having to add a few sweeps under some of the conference room doors in order to make sure that we met that goal in those offices and conference rooms. Outside air rate, we did achieve that. We sized the system to be 30% larger than ASHRAE 62. We do have DCV in all of our training areas. That is achieved, although I will tell you that one of the recommendations from the epidemic task force is to disable DCV right now because it does limit the amount of outside air in a space. And right now with the pandemic, the recommendation is to increase outside air into space. Daylighting, our goal was the majority of occupants to achieve daylighting 55% of the time. We got 57% on the upper level and 23% on the middle level. Some of that was a marry between cost and the ability to meet this goal, because to change out some of the windows and the heights and all was going to cost more than we ended up wanting to spend. And then resiliency, we defined our goals and we met those goals in the project. We do have enough funding remaining in the project to be able to install our photovoltaic system. So we are putting in a new solar PV system, which is in the process right now of being installed. We estimate it's going to be completed sometime in the late April, May timeframe this year. And so this is the system size and the estimated energy production for this system once it's installed. Some lessons learned from the owner's perspective. So I don't work for ASHRAE. I'm a consulting engineer and a commissioning agent as well. But there are a lot of lessons learned from this project because I was operating in an owner's representative role, if you will, with the building ad hoc committee. You know, understanding the market. Atlanta is a very hot market. Everything is expensive in Atlanta, including real estate. Finding property downtown that you could, property would get snapped up as soon as it came on the market. So understanding the market is a very good lesson learned when you start out on a project like this. Early goal setting in the OPR. So we had a technical advisory subcommittee that completed the owner project requirements. And that was done before the design team selection, and that helped everybody understand what we were trying to accomplish on the project. But our early budgeting was done before we did our OPR. So there were some things with our budgeting that we didn't account for, such as the amount of the envelope improvement that had to happen to meet the EUI. We anticipated changing out windows. We did not anticipate having to completely redo the entire envelope in order to get our energy use down. And condition assessment and building infrastructure. We did some condition assessments before we purchased the building, but once we got into the project, it was pretty clear that the plumbing system in its entirety needed to be replaced. The fire protection system in its entirety needed to be replaced, and the main electrical switchgear also needed to be replaced. So those were budgeting items that we decided to go ahead and do at this time. We had a very supportive board of directors that said, yes, let's go ahead and do it now so we don't have to do it 5 years from now. And so we ended up having to increase our budget to accommodate these items. So that's my portion of this from a owner's perspective, and I'll turn it over to Darren to talk about commissioning.
Thanks, Ginger. Hello, everyone. Glad to be here. I see questions have been pouring in, so I'm going to try to get through my slide deck in a timely manner and leave time for questions on the back end. So certainly a question for this group: what was the onboarding process like for commissioning? When did we get involved? And what did that process look like? So Ginger laid out the foundation for that a bit by establishing that the OPR was critical to the project. and was developed early on by ASHRAE. As a commissioning provider, the teams were interviewed early in the process, but after OPR development, very much in line with when the design team, construction professional were brought in, but it allowed for very early engagement in the early stages during programming. And that gave us the opportunity to provide input to ASHRAE, to the design team, with regards to our concerns for maintainability, accessibility, sustainable goals. Some other things that were important as we were onboarding was we were made aware that the budget was pretty tight. Donations were a possibility, but not a given. So that being the case, on a tight budget and not being able to assume donations meant that the team had to be creative. And Ginger laid out the two main design options for you from an HVAC perspective in particular that kind of illustrated the repeatable and cost-effective solution that can be done in similar applications and have a very good energy savings potential. Though, as she mentioned, ASHRAE being on the forefront of the building industry, wanting to be, to be pushing things forward a bit, and so we ended up with the hydronic system. And I'll talk a little bit more about some of the things we took away from the commissioning process here in a minute on that. Also, coordination with MEP trades. So when construction began or was getting going, the trades were coming on board. Construction market in Atlanta is still very hot, very busy. Most of the major trades were pretty well tied up. And so I had to think about what that trade pool would look like, especially after there was direction on the MEP design and how ambitious it was going to be. So from the schedule itself being pretty tight, as Ginger laid out, the move in was set, the move out of headquarters in Thule Circle was set. We had to deal with that, the systems complications, knowing that they were a little unique to the Southeast and the extremely busy construction market at the time. And so it led to many questions from the subs, particularly the HVAC subs. And so you'll see why more of that as we go forward, knowing that, radiant panel system is pretty atypical in the Southeast. We have chilled beams, often active chilled beams in the Southeast is becoming more common, though still not the norm. Passive radiant panels is pretty new. And so created some interesting questions from the marketplace. Ginger, if you'll advance for me, that'd be perfect. Thank you. So then we get into the design phase, and what are we doing? So as I mentioned, we were on board early, so we were able to attend programming workshops and have some input. Talked about what the pros and cons would be of the two main HVAC options, from costs to maintainability. Well, these were important topics. Provide that input and be honest about it. And everybody at the table, the great thing about this is there were so many people at the table, and everyone being knowledgeable in the industry. The conversation was good and was honest between all the project stakeholders. So during design review, some of the more nuts and bolts of it, to be efficient, we utilized design reviews by conducting design reviews, in Bluebeam. In general, we do this in many projects at Epsten Group, but this allowed us in this particular case to be very efficient on a tight design timeframe to send comments via Bluebeam sessions, have that open for the design team to see, entertain, and respond to directly. And we found that to be very effective in having our back and forth at each major design deliverable. Helped to expedite and close out those comments in a timely manner. And then additionally, we laid out our commissioning plan, laying out roles and responsibilities. And this is common on every commissioning project, but because it was established early, we had roles and responsibilities that were set up for the entire project team, from the design team through the construction team, all of us working together in the commissioning process from the outset of the project. And communication protocols was important. Certainly ASHRAE being the gold standard for HVAC and really building systems in general, and having written standard 202, the folks that were going to be involved, we knew would want to keep abreast of the commissioning process and be closely tied to that. So we had numerous members from the from the ASHRAE ad hoc team in the loop on our commissioning process from the outset. So in construction phase, a couple things here before I get into some of the key takeaways. Submittal reviews, again, this was really important. Schedule was tight. Submittal reviews for commissioning, we want to do concurrent with the design team. That way the construction professional gets one set of comments back. And so on a tight time frame, they had to be doing that pretty efficiently. So it was pretty constant communication with the design team. They were very cooperative and collaborative. The Hauser Walker Integral design team was great to work with. In that process, we also had to look at the long lead items. Those had to move quickly. And it ended up being that several of those items would end up being donated. So there were some interesting complications to that, given that it was donated equipment's being given to the project. So technically the contractors aren't buying that and supplying it. There are some projects where that's the case, but it made it, certainly a little bit more interesting in the submittal process. And then site visits, as is true with most commissioning projects, we're looking for accessibility, maintainability. We observed duct and pipe pressure testing and observed equipment startups, and in general, just had pretty routine on-site presence. That's not always true of commissioning projects, but this one is as high profile as it was. And with systems as sophisticated as these, that was an important aspect of the process for us. And then pre-functional checklists were really important. We had radiant panels, we had six-way valves, we had a lot of unique components that we wanted to make sure had installation checklists for them. We created them at Epsten Group, managed them online to be efficient and transparent. The subcontractors executed them. And because these are some unique systems, as I mentioned, they got a little bit more attention with these checklists. And then lastly, issues tracking were managed in real time online. Everything was managed online. You see some snapshots there from our tool. The tool we use is CxAlloy. We discussed those issues in OAC meetings and commissioning meetings, and they were treated just like any other site visit walkthrough issue from the design team. There was emphasis on them. They were not ignored and sitting on the sidelines, which was really important to successful commissioning process delivery. So what are some of the key takeaways? There's a few I'd like to go into. The first one that's obvious, and Ginger touched on it in a few ways, was COVID. So many projects experienced this that were coming out of the ground already or in the midst of renovation. And we had to make adjustments in real time in construction. So a good chunk of the construction duration was impacted by COVID. So basically March of last year through the end of the year, as we were finishing up the project, led to some changes. ASHRAE Pandemic Task Force, I've got a note there on the right that was actually directly from that task force about making modifications to HVAC control strategy on the go in response to COVID. And then Ginger mentioned just a minute ago some more input regarding demand control ventilation adjustments. So between that and the on-site work impacted, where face masks, social distancing, regular temperature checks, this is all stuff that was in addition to what was already being managed by the construction professional Skanska that had to be dealt with, and all of the trade partners had to be diligent about it and safe. That also, a couple other things is, in some cases, maybe folks that were impacted by this would be able to absorb schedule adjustments and basically slide the schedule back a little bit. It wasn't really practical here. There wasn't really room for that, though ASHRAE was going to partially occupy, because of COVID, it wasn't as simple as just saying, well, we'll just delay move-in. They had to move out. So, there wasn't a big schedule impact that could be accounted for. And then because of COVID, a lot of vendors, a lot of equipment vendors basically shut down all travel and stopped people visiting sites beyond what was absolutely critical. And so that on-site engagement was impacted. And that was important when it came to donations. We still had that cooperation, but it was not as normal. So there was time lag as a result of that. So donate equipment, mentioned this a few times. The thing worth mentioning here is that, because the subcontractors would install this equipment but not provide it, there's always some nuance to that when it comes to ownership and how much ownership does that sub have. And we were fortunate for the most part to, for the subs to really just buy in and understand the importance of installing the equipment properly, owning in the startup process, making sure everything was going to go smoothly. But it's still not the same because they don't technically own that equipment. The other thing is, because this is for ASHRAE, there's a lot of state-of-the-art equipment. It's brand new equipment. I'll talk about a couple of those things, including the DOAS unit. Ginger mentioned the heat pump chiller and how sophisticated it is and how it works. And it had some sophisticated controls on it for it to do switching between heating and cooling in each module. So there's some complications to that. That was new to many of not only the subs, but even some of the field reps for the vendors made that a little bit challenging with startup and checkout process. Vendor communication and engagement, largely again due to COVID, was a little bit tricky, especially as we got towards startup, checkout, and commissioning of equipment when we couldn't have people there on really short notice as we might otherwise have given travel restrictions. And then BAS integration. This is a issue, or a complication is probably a better word on every project, but especially with more sophisticated systems, what level of BACnet integration or BAS integration is required? How do you go about it? Needing the infrastructure for that. The BACnet points list is just the starting point. So you see some correspondence there where we ran into some hiccups with that integration and working through the kinks of that continued on for a little while. Again, mostly because it was harder to get, we couldn't get everybody in a room in the midst of all this. And so it made it a little more complicated as we had to work through it. Okay, so some other items that were interesting, and this one's probably the biggest one just from a commissioning functional performance testing and checkout perspective, was hydronic system. So not just that we had six-way valves, which I'll talk about in a second, but that it's a radiant panel system. We have a bunch of different zones that are running together. We got this heat pump chiller that's trying to produce 52-degree water, which it does quite well, but then we need to send a warmer water out to the zones. And so you see a diagram there, and I apologize for the busyness here, and it gets into the weeds, but that's kind of what we do. So hopefully it makes sense. So we're blending water to allow to elevate the temperature into the secondary side, and then sending that warmer water out to the system, so that because we're naturally in a radiant system like this, you're going to use an elevated chill water temperature and a reduced hot water temperature. And so again, we ran into some complications with this, with the piping configuration. You see an example from drawings where we made some tweaks because of the pump selections on this project, again, which were donated. We had to tweak the piping configuration due to some pump conflicts and fighting each other. And actually that transitions pretty well, Ginger, to the next slide. So the pumps, you see a view of the pump curve there. It may be a little bit difficult to see, but that's the multiple pump curve. And one thing that should probably stand out to folks is that we're moved down up the left a little bit on the curve. And that means basically as we increase pressure drop, we reduce our flow capabilities pretty quickly. And that's just an inherent setup with this pump configuration and the pumps we have. This is actually one of the better options we've had for this configuration. One thing that's worth pointing out is that we didn't really touch on at the beginning, but these are very small pumps because it is a passive radiant system. These are 3 horsepower pumps nominally for the primary, secondary, slightly different than that. But generally speaking, they're very small pumps. And so that made for some complications that we've had to work through. The other thing you see there is the chiller strainer. So we kind of took these things in bites as we went along through the tab process to figure out, well, why are we a little bit short on flow? The chiller manufacturer required this 60 mesh strainer to protect the chiller because of the heat exchangers we have. So for it to work, which works quite effectively, we had to protect it. But you see that buildup effectively deteriorated our primary flow until we dropped it and cleaned it a couple of times. And we worked through that. Next, thank you, Ginger. And then the 6-way valves. So certainly this was intriguing when we first were engaged in the project and the system selection was done. How does this 6-way valve work? So, and a question's actually already been raised about this. So how does it work? It's effectively 2 3-way valves tied together. You can see in the diagram, or excuse me, in the photos there, top right and then right middle, a cut through of that valve. And this valve can modulate. It's actually a pick valve. It can do position control or flow control. And so it moves between heating and cooling. There's a dead band in the middle. Basically, the middle third is isolated and closed. It's heating and cooling on either side of that. And so then they can flow control for meeting a design flow or position control. And so we had to work through some complications of this. I got a couple more slides on that, but I want to talk first about what we ran into because of the system's pressures. So these six-way valves, a couple of unique things about them. Often we're selecting control valves between a 3 and 5 psi pressure drop. That's pretty common. These were donated as well. The initial batch had, you can see in the chart there, a range depending on the size of the valve from basically 2 to 3 psi drop all the way up to 12, almost 14. I think it was 13.5 psi pressure drop. And that creates some complications when you look at the fact that we've got pump curves the way that they were, and you've got circuit setters in the system to proportionally balance the system. So that led to some flow limitations that we ran into and have been working through since then. You see a bunch of data here to kind of show that. Because these are PIC valves, that extra characterization is built into them. It's actually come down since then. They put new characterization discs in this model that has allowed that to come down a bit, but it was still an interesting wrinkle in the project. So on the next slide, what did that mean? What do we have to do about that? So you see some results from the tab data. There's diversified flow from the total connected load to the pump capacities, which is pretty common, but you see some notes there about how we were short on total pump performance when both pumps are running. We also had the circuit setters used, and as is standard in the industry, both AABC and NEB to do proportional balancing on the water side. Actually found because there's a fair difference between the lowest flow at the maybe the lowest case zone, the lowest demand around 1.5 GPM, up to some zones had as much as 12 GPM demand. There's a fair amount of proportional balancing that was required to meet each individual flow rate, but the end result was that we diminished overall system flow. And so basically since then, since we worked through all that, the project team, commissioning team, controls contractor, sub, the mechanical sub, we went back and made adjustments, opening up circuit setters, setting the six-way valves to straight PIC control, flow control, which limits the max flow through it, and it actually actively controlling to that. And then we're just now had a call this morning to go remeasure these pumps again, which we expect to be a very positive result. There hasn't been any significant detriment so far. As Ginger mentioned, the building's not been entirely occupied, but it was noticeable in some areas that we were short of water flow. And so we've been working through that with this interesting combination of new valve type and the means of which they control. A couple more things, the DOAS units. So again, state of the art is easy to say for this project. These DOAS units had brand new controls on them, the latest version. And so it was even a little bit foreign to some of their startup guys. And so we had to we've been working through some hiccups from that, involve what is that operating system? How does it configured with factory defaults for exhaust fan static control, the dew point control that's integral to the DOAS units. Integration was a little messy out of the gate, not having the same data available. The points list was not as robust as it was for the same vendor for the chiller, so we had to work through that, and some underperforming exhaust. And there are a couple of reasons for that. Main reason was that the filter loading wasn't fully accounted for in the submittal of this DOAS unit. Again, it was donated, so we had to work through that a bit. You see some in the bottom middle there, some tweaks to the ventilation numbers and the exhaust numbers in the general areas done by the engineer to allow us to basically accept that setback a bit and account for some filter loading. And so, made for some complications to it. And then, we're still working through a couple of little things with regards to that, but the biggest parts are behind us at this point. And then the last slide I've got, and we can open it up to questions, was just systems operating hours and recovery. And that's relevant because, it's a radiant system. So unlike a forced ventilation overhead where you could turn a system on at 4 or 5 in the morning, 6 in the morning, and recover to occupied conditions probably within an hour. That's not really true in a radiant system. So initial occupied hour set points were pretty traditional office space, and there's nothing inherently wrong with that, certainly for space temperature controls, but the setbacks were too long. Basically, our unoccupied condition was too long. And so we have since modified that to allow for a quicker recovery and less downtime. We already have a very efficient system, so this modification is pretty harmless to energy performance for the building. And so you see some of the adjustments were made there, and a trend chart there that shows you see those drops over a weekend and a quick spike to show how quickly our heating, particularly on our heating side when we made this change in early March, to see how fast our system recovered from there. And so that are the big takeaways for the commissioning process. The last thing I'll just say is it's been a fun project, great to work with ASHRAE on. They strove for some major goals, and as a commissioning agent, I tend to be a skeptic of all things and try to work through them and see how it works. And I, to be honest, have been pretty impressed with everybody, the systems approach and the project team and the commitment to it from ASHRAE on down. So it's been a great project. So at this time, I think we've got about 10 minutes or so left. I think, Sam, we can open it up to questions.
Yes, thanks so much, Ginger and Darren. We have a decent amount of questions come in. If anyone else has some lingering questions they want to ask, submit them to the Q&A button, and we'll try to get through as many as possible. So the first one is for Ginger. This was sent in on the owner project requirement slide. They stated 0.04 watts per square feet. That's less than 10% of the typical. How is that accomplished?
So we're still measuring that, right? So we don't know where we're going to end up. And the way that was accomplished on ASHRAE's side was they transitioned everybody to laptops so that they could make sure that everybody took their computers home at night and things didn't stay plugged in. Plus the fact that we have our a lot of our outlets, especially for our training center and other areas, on a timer, if you will, so that they turn off and off hours. So we don't use, and we don't have any parasitic plug load in the unoccupied time. Like I said, we're still measuring that situation. So my hope is that we can report that we have met that goal.
Thank you. Next question is the ventilation system constant volume, or is there an IAQ control for the VAV sequence?
So for the Learning Center, it is based on demand control ventilation, or it would be if we were not in the middle of a pandemic. And so it is at that point VAV for the Learning Center area. For the remainder of the building, it's constant volume for the remaining occupied areas. I'm pretty sure, Darren, right?
Yes, that's correct. We have basically constant everywhere but the high density spaces, and constant exhaust. The constant exhaust is primarily set up. We have some general exhaust, not just from the bathrooms, that is primarily for mass flow balance on the energy recovery side of the DOAS units.
Great, thank you. This next question, I think, Darren, maybe you want to answer. Why did you want to exceed your ventilation rate to be 30% greater than the ASHRAE requirement?
Ginger, I think you want this one.
So our technical advisory subcommittee, this was one of their goals, which that everybody feels like in the pandemic, I guess, has proved it out, is the more outside air, the better. But we only want to do that when it doesn't a detriment to energy. So that's the reason for the demand control ventilation, the high occupancy areas. The DOAS unit was designed to bring in a lot more outside air for those high occupied areas, our training rooms and our boardrooms, so that, you know, when people are in there for 6-8 hours a day, you get a pretty good exchange rate of airflow. So, but we don't treat that on a normal basis because, you know, the buildings aren't used on a normal basis. And when the CO2 levels are low, then we don't have to bring in that much outside air. But that was a goal for our technical advisory subcommittee.
This next person's asking, any issues with setup of valve timing of heat recovery chiller during shoulder months?
That's a yes. There's actually, it may not have been entirely clear, but there are bypass valves around the chiller. So if it's not in heating on one side of the module or not in cooling, we are bypassing around. And actually, when we're not running the compressors actively at the time, we are bypassing around it. And what's interesting about that is in the shoulder season, of course, we're coming in and out of that. And these valves, pressure drops were not exact across that valve versus what goes through the chiller heat exchanger. And so we actually had to tweak not the timing, but the actual stop position on those valves to try to keep the, what we were seeing is that the pumps would begin to hunt a little bit on DP as that valve opened and closed. That's a chiller controlled device, but the pumps are BAS controlled. And we would see this during testing in the shoulder months really last fall. And so tweaking the parameters on that and the mechanical stop actually on those control valves helped that really dampen that problem. It was a relatively minor problem, honestly, but something we wanted to sort out.
Okay, this next person's asking, for your OPR plug load goal, does the area used to determine the wattage limit include the lower floor? Also related, can you share what the expected full-time building occupancy will be?
Yes, so I would say that to answer the first question, yes, it was across the board plug load for the square footage, and the lower floor right now will be primarily storage. So that will help with some of the load on the upper floor. So I would say that's a yes. Secondly, on the second part of the question, sorry, can you read the second part of it again?
Sure. Can you also share what the expected full-time building occupancy will be?
Right around 100 people. ASHRAE has had somewhere between 95 and 110 employees. And so that is and there's room for growth. Obviously, this site sits on about 10 acres of land, and there's a lot of parking, which we're able to use some of that for the PV array installation. But yeah, so the right now the occupants will be somewhere between 95 and 110.
Okay. An attendee is wondering, was there a leaving humidity control for the DOAS system? They appear to be the only humidity control device.
Yeah, I'll answer this one. And there's 3 or 4 questions that came in on this. So I'll try to bundle them together to make sure I hit on all of them. So the DOAS is our dehumidification infrastructure. It's as you have heard, it's decoupled from the heating and cooling for the building, but it does provide our ventilation and our dehumidification. So it is running off of dew point control. In the summer months, we are resetting downward on temperature as we see elevated humidities in the space. So one of the questions was about, have we seen any problems with, basically sweating or humidity control for these radiant panels? So far, the answer to that is no, not since startup and the building integrity, basically building dry-in has been completed. But it is important that the DOAS unit continue to function and provide dehumidification and reset downward to ensure that we do not have conditions where we could hit the dew point and sweat. Most of the piping is insulated, but when you get to the panels, it is you saw some of the photos where it is loose. And so that active reset has to occur. Not to mention, we also have elevated water temperature on the cooling side. So in theory, it'd be pretty hard to get to a dew point, place on dew point where we would sweat, but it is always possible if you send the wrong water temperature down the pipe. Hopefully that answers 3 or 4 of those humidity questions that were brought up that are very relevant and very common when we talk about chilled beams or radiant panels in the Southeast.
Thank you, Darren. Yes, we did get a couple of those come in. Next question. With COVID having lower building occupancy following project completion, were there any tests conducted on the building systems to stimulate a higher occupancy load to verify performance meeting the design requirements?
So the short answer to this is we didn't put 100 people in the building. So we didn't do it in the traditional way. But I mean, we did have the units online, basically the entire system online in the late summer, early fall, and it was still hot. We still had 90+ degree days. And because a ton of our load is the outside air, certainly on the latent side, we simulated a bad condition, a heavy load condition, and we had to work through that a bit. We did have some hiccups with controls on the DOAS, as I mentioned, trying to make sure we're hitting set point and not shutting any of the compressors down. But we did push through that. Now it'll be interesting to see how it works once we put 100 people plus people in the training rooms and see how everything comes together. Hopefully we will get to see that hopefully, fingers crossed, by the time we get to the end of this coming summer. But we shall see. Because a ton of the load in the building is sensible, or our response to it is largely sensible. We simulated it in the zones where we have radiant panels simply by allowing the temperature to increase and then subcooling down to see the response. It's not a perfect way to address it, but it was what we had available, certainly.
Great. So we are nearing the top of the hour. I just want to see if we can sneak in a couple more questions before we close out the day. Someone is asking, what was the material that was clogging the strainer that you showed? Was the system not flushed thoroughly the first time?
It was flushed. It was flushed multiple times. We had to I showed a diagram where we had to tweak the piping. And so when you do that and modify some piping on the go, you're going to reintroduce new water, and you can bring materials in. But a 60 mesh strainer is very fine. I mean, you can't put coffee through it, but you can't brew coffee with it, but you could do pretty close to that. And so it doesn't take a lot to clog it. But it's been checked several times since then. We have not opened that system up again. So the couple times the strainer's been dropped, has been in much better condition.
Okay, one last question. Someone is wondering, what is the background CO2 for Atlanta? They're noting, they're asking that the note about the 350 ppm must have resulted in continuous overventilation of the training spaces.
Ginger, you know about that note?
I don't know what it is for Atlanta. No, I can't answer that question.
I can tell you the general baseline in Atlanta is between 400 and 450. And if we had set points, the CO2 set points are commonly adjustable. A very common setting is 700 ppm over baseline, and then a range. And I can't recall what our exact settings are right now, but it's been tweaked as a result of COVID anyway. So we're probably are over ventilating, and that would be on purpose for the time being until we get out of pandemic mode, I am sure. Hey, Sam, there's one other one that might be worth addressing with a couple more minutes, and I don't know, Ginger may have a thought. It was about the air leakage rate for the enclosure. We didn't spend a ton of time in questions on the enclosure, but I think they're worth mentioning. I'll just mention it. What was air leakage rate for the building envelope, and was it achieved via blower door testing?
So we did do blower door testing. We did have an air leakage rate, and I'm trying to remember if it was 0.11 was the goal. We were not able to achieve that with our new envelope. There were a lot of reasons for that. Mainly there was air that blew back through the DOAS units on the pressure test, and a couple of other areas that were identified by our blower door company. We did do the test once, and the contractor had to come back and do some mitigation because there was a lot of leakage. And then we did the test again, and we got it down quite a bit, but not to the goal. But if you consider the fact that when we bought the building, we did an initial blower door test, and they said that we had equivalent of a size opening of a 10-foot by 10-foot opening in the building. We improved it quite a bit with the envelope improvements that were done.
Yeah, I'd echo that. I wasn't on site for that final test, but we all saw that building several times in early demo, and it was a sieve to the exterior, and is a lot of why the systems design works is because of those enclosure improvements, and so that it's really hard to overstate the importance of the enclosure to the design strategy and the end performance of the building.
Great. Well, Ginger, Darren, thank you so much for your time today. For everyone else attending, thank you for stopping by. This same time, Thursday, we're coming together again to bring you a case study on microgrid commissioning, and we hope to see you there. You will receive your certificate of attendance in 24 hours via email, and then the recording of this session will be available in 1 week for viewing. Stay safe, stay healthy, and thank you again for joining us.